Bueno, voy a presentar el trabajo titulado Sistema de...
Well, finally, I will introduce this paper entitled People Location System in Residential Areas and its Visual Interface. This is a location system that is worthwhile indoors and outdoors, and this monitoring system for the location of people within buildings as well. This is a script introduction where we are, the targets of this type of services, and the uses of these location systems, and then we will discuss this location system, which is made up of a module, location module, plus a service module. And here we will talk about the structure and implementation, and we will finish with some conclusions. Let me give you the context first. Our society is aging, and it is expected that by 2050, 30% of the EU population will be made up by people over 65, which is twice as much as in 1995. And the governments are also paying special attention to people with functional diversity, and one of them is the long-term care act in Spain. And we also have the fact that parents and kids pay a lot of attention to personal security, and that's one of the reasons why mobile phones are used so early by children. These services for this group of people can be provided by qualified personnel that offers a high demand, or by technological assistance systems which are more scalable, although not everyone can afford to buy them. And then we also have hybrid systems that include technical solutions where qualified people are overseeing the system. This is also a scalable solution and would be more economic than the previous one. Therefore, this indoor location system can be extremely useful for these groups of people, as long as we take into account ethical parameters. Regarding the use of location systems indoors, they can be used in day centers, or in institutions, in daycare centers or night care centers, schools, hospitals, malls, industries, or anywhere where there are critical situations, and they can use a visual interface to see the facilities, to try and locate the position of the persons inside of those buildings on the premises. We have a location module that will identify the position regarding the antennae within or and outside the building. And then we also have a service module that provides information based on the location obtained by the other module. The location module is made up of a number of antennae, and they need to be installed in the building appropriately, and also the location devices that each person will carry on him or her. It is important to identify where they will place them, because they usually have them hanging from a bracelet or on hearing, but they should be also included in the everyday devices, for instance, in the shoes, in the walking stick, or in the wheelchair. It would be more interesting to incorporate them in these elements that they wear every day. Let's talk about the different location systems. We have GPS systems and the Galileo and GLONASS. These two latter ones are incomplete, and none of them offer good results indoors. What about indoors? We have systems that are based in signal triangulation, such as the Bluetooth indoor positioning system, or the radar, which is a similar system but based on Wi-Fi technology. They are based on the reception and error in sending packages, and well, they are based on the transmission error approximation based on SIG-B technology. It works as follows: the emitters send packets with a given intensity until the packets don't get there, and that determines the estimate distance of the person. And finally, the last family of techniques are based on steps. Jetta sandals adds the number of steps taken, and they obtain a position based on the initial position. It's quite a well-known system. Each one of the systems has pros and cons, and depending on where they're based, they will be better or worse. I would like to underscore a few features. For instance, if you use a signal triangulation-based system, you need a number of antennas. For Bluetooth, one every 10 meters, and these antennas need to be synchronized. And the other system that is based on the reception and error of packages sent, it requires sending lots of packages for each cycle. This means a high energy consumption because people will be wearing a device, and these devices have batteries. They have a limited amount of time. And those, the systems that are based on steps, have a con of the fact that each step has got a partial error, and these are cumulative, and then there are more errors if there are steps or obstacles along the way. Once we have analyzed the different techniques, I will tell you about what we propose. We propose a location method which is based on differential techniques that are based on multi-frequency waves placed in the reception. So we're sending a single signal made up of different frequencies. When it goes through different environments, there's a delay in each frequency, and the receptor will measure that delay and therefore can calculate the distance. And these differential measures offer advantages when synchronizing the devices, and they simplify the facilities, the equipment, and maintenance. They, for instance, allow for one single antenna to be placed there. This antenna will measure the delay, and we also need to understand that these time differences between the different antennas are nanoseconds. Nanoseconds. This requires high precision, high accuracy devices. Electromagnetic waves interact with the medium that they go through, and that will have to. The result of this interaction depends on the characteristics of the signal, of this multi-frequency signal, the frequency, amplitude, polarization, and so on, and the features of the medium will depend on the permissivity, conductivity, permeability, and so on. Therefore, there will be different measures according to the places. This interaction allows us to define the medium based on the distance between the sender and the transmission, the recipient, and the transmission, the features of the signal, and the delay between each frequency, and it will determine the distance between the emitter and the recipient, knowing what type of medium that they're going through and the types of signal. We can identify the interaction between the wave and the medium, and if we have a good calculation of if we have good knowledge of the wave-medium interaction, we can locate the distance, and that's what we use. Let's have a look now at the service module. It offers location-derived services, such as, for instance, identifying the real-time position of the person, having a list of historical movements, a log of where that person has been, for instance, obtaining patterns, or sending a warning when there's an unusual behavior, or when the person goes into an undesirable area or place. This is the difference between three areas. That's the screen. The first one is the main visualization area, and here you see the map of the building or of that story and the persons that are being monitored. The second part of the screen is the control area, where you can monitor the simulation and the environment. And the final one is the secondary visualization area, where you have elaborated information through a text